Hello friends. This video is brought to you by mywayteaching.com.
Let us read the question. A farmer and his wife are busy making jaggery out of sugarcane juice. They have processed the sugarcane juice to make the molasses, which is poured into molds in the shape of a frustum of a cone having the diameter of its two circular faces as 30 centimeters and 35 centimeters, and the vertical height of the mold is 14 centimeters. If each cubic centimeter of molasses has mass about 1.2 grams, find the mass of the molasses that can be poured into each mold. Since we have to find the mass of molasses that can be poured into each mold, we need volume of the mold. And volume of the mold will be equal to volume of the frustum. Let us recall the formula, where R1 and R2 are the radii of the ends of the frustum of the cone, which are given to be 35 by 2 centimeters and 30 by 2 centimeters. Let us substitute the values in the formula. Height of the frustum is given to be 14 centimeters. R1 is 35 by 2 the whole square plus 30 by 2 is R2, so 30 by 2 the whole square into R1 R2 is 35 by 2 into 30 by 2 7 2 times 14 gets cancelled. Here we can get 35 whole square by 4, 30 whole square by 4 and 35 into 30 whole by 4. We can take out 4 common and hence the following expression is left with us. Solving further, we get volume of the frustum or the volume of the mold equal to 11,641.7 centimeter cube. It is given that 1 centimeter cube of molasses has mass 1.2 grams. So the mass of molasses that can be poured into each mold should be volume of the mold into 1.2, which comes out to be 13,970.04 grams or 13.97 kg. Let us read the question. An open metal bucket is in shape of frustum of a cone molded on a hollow cylindrical base made of same metallic sheet. The diameter of two circular ends of the bucket are 45 centimeters and 25 centimeters. The total vertical height of the bucket is 40 centimeters and that of the vertical base is 6 centimeters. Find the area of the metallic sheet used to make the bucket where we do not take into account the handle of the bucket. Also find the volume of the water in the bucket. Firstly, let us try to analyze what will be the area of metallic sheet used. We need the curved surface area of the frustum. We would also need the area of the circular base of the frustum and the curved surface area of the hollow cylinder that has been attached to the frustum. Let R1 denote the radius of bigger base of the frustum, which will be 22.5 centimeters, and R2 denote the smaller base. So R2 will be 25 by 2, that is 12.5 centimeters. We would also require height of the frustum. Total height of the bucket is 40 centimeters, but height of the cylindrical base is 6 centimeters, which we will subtract and get 34 centimeters as the height of the frustum. Now area of metallic sheet will be given by pi into L into R1 plus R2, which is the curved surface area of the frustum, plus area of the base of the frustum will be pi R2 square plus curved surface area of the cylinder, which is equal to 2 pi RH, where h is the height of the cylinder. So 2 into pi into radius will be 12.5 into h, which is 6 centimeters. We can see that we need L. Let us calculate L first. Slant height of the frustum is given by the following formula. Let us substitute and find the value. On solving, we get under root of 34 square plus 10 square, which comes out to be approximately 35.44 centimeters. Now substituting all the values in equation 1, we will get area of the metallic sheet used. We get the following expression after substitution. We can take out pi common, and hence the area of the metallic sheet used to make this bucket will be 4860.9 centimeters square. Now calculate volume of the water that this bucket can hold, which will be equal to volume of the frustum. Let us calculate using the formula 1 by 3 pi h into R1 square plus R2 square plus R1 R2 . Solving this further, we get 22 by 7 into 34 by 3 into 943.75. Solving this further, we get volume of the water that the bucket can hold will be 33,615.48 centimeter cube. Using the conversion, 1 centimeter cube equal to 1,000th of a liter, we get volume equal to 33.62 liters approximately.